Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 169, that is majority elements. So let us understand the question first. So we are given an array nums of size n. So we are given an array of integers, that is nums. It has size n. Return the majority element, and we have to return the majority element. So what actually majority element is? So the majority element is the element that appears more than n by 2 times. So majority element isn't the one with the greatest number of appearance, it is the one which appears more than half of size of array. That is, if we have an array of size 10, so the element which is more than 5 times, that is half of size of array, is a majority element. You may assume that the majority element always exists in the array. So here they listen our work that they say we can assume that there always exists a majority element. So we don't have to check whether a majority element exists or not. It always exists, so we don't have to care about it. So let us see the examples. In this array, first example, there are like three elements, 3, 2, and 3. So size of array is 3 and half size of array is in integers, it's 1. So the element which appears more than 1 is a majority element, and 3 appears more than once and it is a majority element. In the second array we have like 2, 3, 5, 6, 7 elements, and half size is like 3, and the element which appears more than 3 times is a majority element. So 2 appears more than 3 times, that is 4 times, so this is a majority element, and we are given some constraint. So nothing to say about the question, it is simple to learn. So let's jump to the solution and discuss about the solution to this problem. So our first solution could be a brute force approach that we can go on checking for each element whether it is a majority element or not. Suppose we move to our first element and we go through iterating whole the array to check whether how many times does it occurs. So for our array, example array, 1 appears only 2 times. So when we go on iterating whole of the array, we found that 1 is 2 times in the array, and then we move to our next element, that is 2, and we go on checking if the element already exists. We don't need to count it, but for a brute force approach we will do this for this whole array. So for 2 we have to iterate over the whole array and check how many times it occurs, and we found that 2 also appears 2 times. And our next element, that is 4, let us check how many times 4 appears, and if we go on counting 4's in our whole array, we found that our 4 is 6 times, that is, yeah, and we finally found our majority element. So for this approach we need to iterate over the whole array n times for each element present in the array and check which element is the majority element. So the time complexity for this approach will be O of n square, and this is simply a brute force approach. So how could we do it better? If we are taking O of n square times, obviously I think so, like, yeah, I mean, if we do sort array, it would be better. It would take lesser time, like to sort array, and then we can go on counting sort array. It would take, I hope so, something lesser time, that is O of n log n, which is the sorting time complexity of our array. O of n log n, which is the best time for sorting, because yeah, if we sort our array it would become something like 1 1, then 2 2, then 4 4 4 4 6 times. So, and we have to iterate just O of n times to count the elements, and we don't have to iterate over and over again. So it would take our O of n log n time. Yeah, so what could be our more better approach to reduce the time? So our next approach could be, yeah, this one, I hope so. Hashing would be our next better approach to do this, and it would take us lesser time of n time complexity. So we could do like this. Okay, in our hashing technique we could create a hash map like this, and if we will put the value key value pairs in this. How could we do this? Let us see. Yeah, suppose we have to iterate only O of n time, that is only one time, but we need O of n something extra space for the size of array. So suppose we start iterating from 0th index, that is, and we found element 1, and we saw that it is not present in the map. So we put it in the map and increase its key, that is its value to 1, that is it appears still, it is now 1 times in the array. Now we move on to our second element, and we found 2 is also not present in our map, and we put 2 in our array. We keep on moving and we increment its count by 1, and we then move for 4, it is also not present, and we put it in our map and we increment its count by 1, and we keep on doing this, and we found that, yeah, we again appear 2. So our next element, we increment the count of 2 because it's already present, we don't need to put it in map, and we increment its count. And finally we will found that our 1 will get its value as 2, and our 4 will get its value as 6. And we can now iterate over our map to check which element has more than half of times appeared, that is, which element have more than half of time of size of array. And we can find that our 4 appears more than half of time of size of array, half. But though it is a better approach in terms of a time complexity, it took only O of n times, because we have to iterate once to check, once to fill our hash map, and then we can simply iterate over our hash map to check which element got the value, which element is maximum. But it took our space of n complexity, so we need to reduce this space, and we have a better approach. So the best approach for this question would be, there is algorithm made for this kind of question, that is Boyers-Moore voting algorithm. So what does algorithm tell us? So this algorithm says that we can choose our candidate and check whether it is and check which candidate will win. So what the algorithm says is, algorithm keep on checking if whatever element is this. So the algorithm takes 3 parameter inputs like 2 3. It chooses the number of votes and number of which candidate is to be put. So basically, what algorithm do is, it comes over like first element, and if initially we initialize candidate as -1 and votes as 0. So when vote is 0, we have to choose our new candidate. So algorithm says that when our votes are 0, we have to choose current element as our new candidate. And on incrementing, if the element is similar, we will increase its votes, and if the element is not similar, we will decrease its vote. So in this case, if we choose our 1 as candidate, and on incrementing we find 2, which is not similar as 1, so we have to decrease its vote, and it will again become 0. So for our 0 weight, we have to again choose our new candidate. Now our 2 will become a candidate. Now incrementing, same thing happens, different element, votes will go to 0, and for 4 we have votes 1. But from this time, our votes goes on incrementing up till here, and now when we decrement here vote, still our candidate is 4 because it is in 0. We don't have to choose a new candidate, and here we will again increment the votes. So for the algorithm, it says whatever the final candidate we have, check whether it appears more than n by 2 times or not. But for our question, as they already tell us that we don't have to care about whether there is candidate element or not. So whatever the candidate is left in the end, that will be our final candidate, or that will be our majority element. So let us go through steps one by one, and then we can write a code. So this Boyers-Moore voting algorithm, it took O of n time complexity and O of 1 space complexity. That is our best algorithm. So what the algorithm says, our first step is to find the majority candidate, that is. So we have to initialize something like I votes in candidate, as we already Learn traverse to the array using for loop. If votes equals 0, choose the candidate AR of I. Make votes equals 1 if the current element is the same as candidate element. Increment votes, else decrement votes. Simple, what we have discussed. And the second step is to check if the candidate has more than n by 2 votes. So we have to iterate over the array and make our counter. And if the candidate element appears more than n by 2, and increment counter each time when we found our candidate element. And if our count is more than n by 2, we can return our candidate element that yeah, this is a candidate element. If it is not, we have to return -1. But this is not a part of the question. So let's get and start writing code. So what the algorithm says that yeah, first we have to initialize some variables, that is int candidate okay, candidate equals, we have to give value -1, and our next is votes that would be initially 0. Okay, now next step we have to do our iterate over our array, and we need a for loop for that. For I equals 0 and I is less than full array, that is nums.length, nums.length, and then I plus plus. Okay, so this will help us iterate over our. No, we have three conditions. First, we have to check whether the votes are 0 or not. So if votes are 0, so we have to choose new elements. As initially we have votes equals 0, then we'll choose our current element, that is candidate, will become candidate, will become our nums of I, and we'll increment it votes by 1, votes plus plus we can do, yeah. And suppose this is the situation, and if this is not the situation, so we have to do else if candidate already appears, that is we already have the candidate. If nums of I equals candidate, then we have to simply increment its votes, so votes plus plus. And if neither of the case appears, then we have to decrement its vote. Okay, else votes minus. Okay, so for this we'll get our candidate hopefully, and we have to return our candidate. Yeah, we got it. Let's check if it works or not. Yeah, good. So let's now submit our code and check the time complexity. So we are 99.9% faster, and we use 98.87% lesser memory. So it is like one of the most optimal solutions. So hope you enjoy learning. Thanks for watching.